after this. So, hey, everybody, it's the 29th of April, 2024. This is Cardano Go Live Coding with Blink Labs, Gimbalabs, and friends. And we've been talking about transaction building for the last few weeks. Mix, I know that you've been playing around with transactions, and right before we went live, am I understanding this right? Like you've got some nice validator transactions working, but when you start to try to unlock from multiple validators, we're not getting the redeemer indexes right.
Exactly, exactly. That's the issue. And the problem is maybe this is another things that every Go developer needs to be aware of,
Mhm.
which
So I,
is Go is not
I
deterministic as Haskell is. Because
I can add some context to this.
sure, sure.
So this is a problem I ran into when you're dealing with transaction indexes in Plutus. It's not in actual transaction order. It
Right.
sorts them by the UTXO by the input UTXO ID, and that's how you have to reference them. So it doesn't matter what order the inputs and outputs are in the transaction itself. When you get to Plutus, it sorts them into a deterministic order based on it's like an alphanumeric sort of the input UTXO IDs, and that's how they're indexed. I ran into that same thing when we were working on Bluefin.
I see. But this issue is weird one because there is this evaluate TX function in Apollo which send the transaction bytes to block frost to evaluate to get back the execution units. I mean the CPU and the memory part, and then substitute the one which was entered by user. I mean the developer with the actual correct one, or I mean the least minimum one. It can go above, but well, why pay more? So the interesting thing is there is a function called complete, and in that complete, there is this function for substituting this execution unit. So that function works. It sends the transaction byte to the block process, returns the values, fine. But once after that, again, this function being called by me, it doesn't work. So the order of these indexes or I mean it's UTXOs are fine. They're okay. And this happens every time. Once that transaction being built kind of before I call the evaluate TX. But once I call the evaluate TX, somehow the order change. And the order, because the order changed, now I get nothing from BlockFrost because BlockFrost says, okay, there is problem with transaction. Exactly same thing. So something along the way changes or affect the transaction to have different orders. And that's a weird thing that happens. And still we are looking at what things change the order, like the order of the indexes of Redeemer. I mean, those inputs and the corresponding uh, numbers or index to that. Still, we haven't
Yeah.
found
It's so
something.
it's hard to imagine what else it could be besides alphabetizing essentially the transaction hashes.
Yeah,
So
but one time it doesn't, another time it does, and it is exactly like next line. Like, I don't know what just happened in memory between these two lines. So this is the weird one. And
um,
we face that, that sorting of list is kind of not absolutely not deterministic in Go.
so right before we started recording this, we were talking about a few different things with transaction building. I'm wondering if today we could touch on both of them. Mix, maybe if we went to you first, do you have an example just to show people the shape of the transaction you're trying to build, just so we can kind of look at that
Okay.
together, see that, kind of see where this limit is. But then could we try to keep it, we'll try to keep it short. So if we have like 45 minutes right now, maybe we'll stick to less than 20 to look at this example. And then we can shift over to the example Manuel was talking about, where we get to look at transaction building, but from another detail perspective, this one around timing and metadata. How would that sound for today's agenda?
It is good, but it is not fair. I
Uh,
think Manuel should go first.
okay.
Then I can have the floor and I can, but this
And
is
then you
not
take
fair.
it to the end.
Yeah, indeed.
Sounds okay to me. Manuel, how does that sound?
Good. However, again, I mean, I think my need is rather basic, but yeah, I mean,
No problem.
everyone has to start somewhere, right?
Indeed.
Bingo.
Right, but I mean, let's sorry, everyone is going to need to be able to figure out how to get their transaction on chain.
Right.
So I think it's a good thing, for us to cover, especially while we're having some issues around creating complex transactions, right? Like that's a much more complex and higher level problem, than just being able to send transaction. Like let's assume your transactions are already properly assembled, right? How do you get it on chain? What methods are there? And what ways can we do it, right?
Yeah.
So I think we can kind of like shift direction that way. And, that way these can actually be like parallel things we're working on, figure out how to get the complex transactions working while at the same time implementing, the lower level communication.
Awesome.
Yep,
And
indeed.
Manuel has some thoughts that maybe there is some active talking through Goroboros because of the use case here. Manuel, what's our best approach here? Do you have something that you want to look at together? Or do you want to start by just talking through what you're trying to design?
Um, Wait, I have to order my thoughts. So no, either way, I mean, in general, it probably makes sense on a just conceptual way to maybe for a few minutes think through what would be needed in a more generic conceptual way of how you would create a transaction. And then in my specific case, or let's put it this way, it will probably differ from each endpoint you use, right? I mean, building a transaction will be different if you're talking to Goroboros directly, whereas, or maybe that's a question, will it differ if I talk to
Absolutely not.
Goroboros? Absolutely not, or absolutely?
Absolutely not.
Okay, that is actually one good learning for me then from today.
Right. So the one thing is everywhere we always end up talking about CBOR bytes when it comes to the actual communication between different pieces. There's a lot of places where we have to change that and convert it between various things. But when it comes to what we're dealing with between languages, between nodes, between anything, it's always the same CBOR bytes. And that's what some of these bugs that we run into come from is we're trying to make sure that bytes get assembled that look exactly the same as they would if they were constructed by Lucid or Haskell or right in any of these other things. So but it all boils down to constructing a CBOR payload of bytes.
So,
So
yeah, just Manuel, this is exciting because what is the part of the transaction that you're imagining you'd want kind of more fine-tuned access to?
So I want I want to send ADA, but it's not about sending stuff. It's the ADA is just for having something that the transaction does something to a different address. So I will have two wallets that will have funds, and then so the tool itself would need to or would want to send funds to either wallet, so back and forth basically. So I don't lose any ADA, but I will need to pay the fees. But that's kind of okay. That's kind of the accepted. But the transactions, and that is the important part, I want to have the payload carry the time, and that should ideally exactly be the same time the transaction was submitted to a local node. So then I can see the the metadata in the transaction when the time when the transaction was transmitted versus the time it actually got adopted on chain. And this is going to run for, well, in theory forever, but in practice probably, well, it doesn't matter, but it's going to run. And then it will send this transaction, say, every 10 minutes or every 20 minutes. That depends. I mean, that's discussable. But it will create the same transaction every regularly. So.
Mm-hmm. Mm-hmm.
So I just posted a link into the chat for the Builder Fest workshop, since it was, kind of carrying around a lot of these things, but for the transaction submission part, we have code examples right there using Ouroboros that should be pretty easy to go. So internal.
Oh,
Yeah, TX submit. Right. So TX builder was Apollo. So like we're gonna pretend, that it's perfectly fine, but you can immediately see right here what is our interface for submit. If you look at the function submit TX, what are we asking for? The bytes, right? So, once again, that's what we're saying. So if you were to have gone through this workshop, and I'm not going to like go too much, but it almost goes in this order. So we have like the indexer that's looking at the chain for the right event, right? And then we had the TX builder, which is using Apollo to build the transaction. That transaction could come from anywhere, right? Like it could come from a front end in Lucid or Translucent or anything like that, right? It could come from any other system. It could come from the wallet generating it. It doesn't matter. All that matters is that for TX submit, we get the bytes. So here you'll see we have multiple paths that you could take with that byte, byte array, and you can submit it either node to node, which we have a function for here.
mm-hmm.
The next one down. Yeah. And this is, how we actually submit it. And this would be like the way that Daedalus or, a full node sends it out to other nodes, right? So this is assuming that it's pre-validated. In other words, there's no validation of it done here. This is just the network communication part of it, of how to get it out to another node. And it's explicitly Ouroboros, the connections of exactly what you need to do to configure it. There's not much. I mean, we can scroll through this. You'll see the file's not very big. It's 200 lines. We didn't do node to client, but we have lots of examples of that because we have a TX submit API application,
Mm-hmm.
right? Which is an example of that. So there was no reason to really do it here. And then this is over API, which is, how we could utilize that application when we already had it, which was good for initial testing.
Mm-hmm.
But a quick question, the transaction bytes you pass into that is already the completed, built and signed transaction, right?
Yes, because we have a separate TX builder here, which I'm ignoring because, I'm assuming that you're building your transaction. However, if you wanted to take a look at that, that would actually, be something we can look at. It is a very, very simple transaction.
Right.
So it would be easy to extend and add metadata to very, very easily. So this is the way that we're doing this transaction, though, is we are triggering it when a specific event occurs. So you can keep scrolling a bit here, James, and I can show you where. Yeah, keep going. Yeah, keep going. Okay, stop. Wait, scroll right here. So where we do the submit the TX bytes. So what we end up doing is we build this transaction, right? So you see where we have TX build reward transaction line like 118 right here.
Mm-hmm.
Yeah. So that guy's right down below. So this is where we're building the transaction using Apollo.
Mm-hmm.
So you can see we start off with nothing. In this case, what we're doing is we're building basically a transaction that sends 5 ADA to another wallet. That's all this does.
Right.
So the only thing that you would need to do in your case, Emmanuel, like to change this would essentially be do the same thing and add the metadata.
Right.
Yeah. So
Right,
that,
with the timestamp. And
yeah.
then, you know, so I'm just saying, like, this is an example of a very simple transaction, using Apollo. We have our UTXO list. We comes from our. You'll see we have methods and all this sort of stuff to get all of the different things and put it together. But the end result is we end up with the raw bytes, that we pass to the TX submit module, which is all of the Ouroboros part. So it's really kind of like well split out. So if you look at the indexer is where we're following the chain for all of the transaction events so that we can tell when to do our things.
Mhm.
Right. And then when the indexer finds, hey, it's time to do the thing, right, then it launches the TX builder. And in fact, the TX builder just handles every event. So like if you'll scroll down here, this is just setting up the chain sync. So we follow just two addresses, and then you'll notice that the last thing that we do is we just launch the pipeline. And then that we have an event handler, and the event handler loads the TX builder handle event for every event, right? And that's where we were talking about the TX builder. The TX builder is all Apollo, and then TX submit is Goroboros again of the bytes.
Interesting. Okay, so that is actually something new for me, or at least I didn't understood from last week. So I do need Apollo to create the transactions, and Goroboros, the library itself, is not enough for me to create the transaction, right?
Correct.
Okay.
Goroboros is a network library. It doesn't create transactions at all. If we were to have anywhere that did do transaction building, it would be in Bursa. And that's where we actually plan on putting some of this stuff, but it's just going to be wrappers for Apollo.
Yeah.
So, the idea is we're building all of the low level network stuff. Eduardo has done a lot of work with Apollo, right? It would be a shame to duplicate that. Instead, it makes sense to wrap it, support him, and, make sure that we all work together to find bugs in it, fix it, right? And make it better by, kind of standardizing on the one choice. So we plan on wrapping Apollo for all of our stuff for it, for creating the transactions. But the point being is the separation here is on purpose also to point out that this TX builder could be not Go, right? It could be any other off-chain service whatsoever, from the wallet doing it by you just asking it to try to generate a transaction. It can be done in Wasm with the CML or CSL and Rust, right? And you could be just handing those bytes to us. It could be done in any way. So that's also a reason why Goroboros doesn't care, because it's the network protocol. So it's just assuming bytes. When we deserialize stuff, we even do so different, than Apollo and things like that, for example, because their representation of a transaction is more what you're going to want to use to do things like signing and that sort of things. Whereas our representation is more of exactly what does it look like on the wire, because that's again where Goroboros is designed. Is Goroboros as you want it to talk on the wire. If you're wanting to build transactions and just build like a backend API that's only doing transaction stuff and say it's using some other APIs like Blockfrost or Maestro, or you've written a client for Dandelion, or you're using Kupo and Agmios locally, all of those things. If you're using any of that kind of stuff, right, like you don't need Goroboros essentially at all, because you're skipping directly talking to the network.
But I could still use Apollo to create the bytes and then submit them to any other thing that would take the bytes, like Ouroboros or anything else, like what you
Correct.
mentioned.
You can take the bytes. And in fact, that's kind of what this TX submit here is showing. Is so we have submit node to node, which means we're taking the bytes and we're using Ouroboros via Goroboros to directly talk to other nodes and give them those bytes, right? Using the proper, secret magic handshakes.
Right.
But then there's also our submit TX API, which is just taking those bytes and sending it to any submit API URL, right? Freeloaders, Blockfrost, Maestro, Koios, right? Like your own, it doesn't matter. It's just a HTTP post of bytes,
Right.
right? So those bytes are assembled in this application by Apollo. If you're building it and you're building in Go, that's what I would say you build, your TX building and signing in.
And it would actually be interesting. My understanding, Manuel, of what you're talking about is a helpful diagnostic tool, and that you're looking at the timing between when was this transaction signed, right? That's the last thing we can do with it before submitting it, and actually on chain. And you can
Right.
imagine that that timing might be a little different between some of these submit options and among others out there. Does that start to get at the heart of what you're talking about?
Yeah, well, the whole BuildFest 2024 workshop repository seems like 70% of what I'm trying to do.
Awesome. Yeah.
So
Yeah.
I knew I miss out on the build on stuff when deciding to not go to the BuildFest, but on holiday. But yeah, holidays are nice as well. So
Yeah.
but that is really, I mean, I'll definitely go check that code out. And it feels like it already has a lot of what, at least initially, I want to do with this. I mean, there's obviously other stuff around this, but for now, just creating the transaction will help me a lot. And the other thing, so the signing, I think, but maybe also a question. I think the signing could be done like even 10 minutes before I submit the transaction, right? So the important thing is that I want to create the transaction and write into that transaction the time in the future when I will be submitting it to the node or to the local chain. So yeah, it is about, and then the data is on chain and everybody can use it. So it's not only us that will be using it and providing it, but everybody that has access to the chain can see these transactions and make assumptions on network congestions over time. That's network congestions, maybe a little bit big of a word, but you get the idea. So yeah, I mean, I'll definitely jump. That is all in all itself enough for me to keep me busy for the next week, I guess.
Excellent. Good. I'm looking for just metadata. Mix, do you have handy? Because I'm just dusting off.
Yeah, actually, I wanted to get the mic to showcase. First of all, we have built a simple transaction which you can provide parameters in Andamio CLI. Several weeks ago, we built that. Actually, let me share my screen to show this guy. Uh, do you see my screen?
Yes, that looks good.
Okay. So this is Andamio CLI, which if you, James, kindly provide the link to the repo. We
Yeah.
have, I mean, we don't have the deploy ref script, but we have something called wallet to wallet. So basically, wallet to wallet is a simple transaction builder for sending an amount from a wallet and to another wallet. And here we are having a wallet built in as a wallet that was uh, inserted here, which you can see at the user wallet here. So if you want to see how a pragmatic wallet or a wallet that you want to work in Go works, or how you can create addresses, all these things, you can look into user wallet file, and should be, yeah, this is the mnemonics or seed phrases, and based on the seed phrases, also I'm using Versa library, but it is kind of older version, not the newer version. But this will essentially craft user pubkey hash, user verification key, and user signing key. These will be needed for transaction building in this example. But if we look to the file wallet to wallet TX builder, around the middle of the file, where is it? Here. This is the part transaction building happens, where the add loaded UTXO accept the input UTXOs, which is the user wants to send this bunch of ADA token to another wallet. This will be the place that we are going to add them. And then pay to the address, and the pay to address can be I mean, you can use several other format of same function. So you can have pay to address, pay to contract, and of course pay to address big32. And big32 is a format we normally see in any wallet. As an example, let me bring up my wallet. And then, of course, the amount. And then the ad requires signer, which is not essentially necessary because you cannot submit a transaction which you are not the owner of the UTXO. So you said I don't want it here this part, but you have to make sure the submit TX check for the signature of the user. But this would be kind of easier. And here's the thing I was actually trying to explore and see how we can add and use it. So we have another guy called set Shelly metadata. And set Shelly metadata, if we look into the function, we can see that it accepts metadata, and it accepts metadata in very specific format, which is Shelly Mary metadata. And again, I mean, we can, of course, read the comments about it, but if we look into this guy, like what should be, this is a structure. Well, this doesn't matter. We don't deal with native script. So here's the part, and metadata, accept metadata, and the type is metadata. And if we look, it is an alias of map of int and tag metadata, and tag metadata again is alias of map, a list of a string, and any here is interface. And since I mean, Golang is very strongly typed language. I mean, not very strongly typed like Haskell, but it is a strongly typed. In order to have some sort of generic type or a type, like, as it says, any, you need to have something called interface. And interface, we can talk about interface for a long time, but essentially interface would be a place so you can add your own type or your specific metadata type. And tag metadata, for example, if you want to go with something for NFT, it can be like 721. So it's just, something, but, and I think this would be the guy. But yeah, this is the place we might need to discuss about it. And maybe it takes a full session to how to craft a metadata structure, put that in the interface, and then doing all these things, giving these types of values, and at the end, crafting these metadata and given to the, where is that function? Let me close this guy. Use giving that to, where did I put it? To set Shelly metadata. Yeah. So that would be something that be worth looking into, how to craft and create a metadata. Of course, based on different standards, we can look the CIPs, like what sort of standards exist. And if you want to make your own, no problem, you can make it. You don't have to follow these standards, and it was any, right? But the thing I wanted to show in regards to the uh, that bytes we were talking about all the time is this guy. So this is an example of that seaboard. So once you craft your transaction, building by anything, Lucid, Haskell, JavaScript, Aken, everything. I mean, Aken is a smart contract language, but there is a little bit of chain part for that they're going to add stuff to it. But anything needs to craft this seaboard. At the end of the day, everything they get, process, everything needs to be this seaboard. And once this seaboard is produced, you can send it over wire to anywhere, to a node, to a blockchain explorer, to front end, to another transaction builder, to serialize and deserialize everything. But if you install this tool called Seaboard DI, you need to have Rust. I mean, you need to have cargo in order to install Seaboard DI. And if you write this command, you can deserialize it into this nice kind of looking JSON, but this is that actual seaboard, and it's following the seaboard kind of
And Nick, I
Yes,
just threw another link in the chat. I have a new favorite tool from the Cardanium folks called Sequisitor. For anybody who hasn't seen it yet, I really recommend taking a look.
the
Threw it in the chat right here.
let's yeah, let's see. Is it seaboard related?
It is.
Cardano?
It does a bunch of different serialization and deserialization, so you can select the tool from the drop-down menu at the top.
Seaboard to JSON, decode to CLS. Okay, let's try it out. So decode to seaboard JSON structure. This Plutus. So we have some Plutus. I can uh, use it actually, but let's for look into the decode to CLS to see.
Try the Seaboard to JSON. Yeah,
Okay,
with the transaction
seaboard,
hex.
seaboard to JSON. Where can I? Okay,
Yep.
so this is nice, but it's kind of too much. Uh,
It's more than you need.
you know,
Hold on. Not Seaboard to JSON. Hold on. Yeah, that's not it.
CLS, no.
No, then you got to
Signature.
check. No, you can do that. You can do the CSL one, but then you got to choose from the other drop-down menus there.
Where
So
where drop down?
one
Which
of the
one?
menu items was decode by I guess it is that one, decode by CSL, but then you'll see there's two more menus that pop up. And so we're looking at a transaction
I
and
see.
choose the, now you
Yeah,
could choose the network, but it looks like it's inferring it correctly.
exactly. It is complex, but I like it. Since I like the complex one. So essentially, this is using the CDDL as well. So for example, here we just see, okay, there is tag 0 and bunch of things in a list, or tag 1, bunch of things again inside the list. Or there is this another tags 18, 14, and sorry, this tool use the CDDL we talked about last week, and now convert that to their actual names. So the tag 0, you see that 0 is input, great, and the outputs, the fees, TTL, uh, cert we don't have, withdraw we don't have, update I don't know what is it, but we don't have. Auxiliary data hash, we don't have auxiliary data, I think would be the metadata, I think. Validate a start interval, yes, we don't have, yes, we don't mint. Yes, we are not minting, we are burning. It ends up in the same place. That's why it's -1. And script data hash, it still is puzzling me what exactly it is, but yeah, collateral, let's see. But I mean, network ID, we don't have collateral return, nothing, no. Okay, reference input, this is the tag.
The script data hash is one of the most complex hashes there is. It's like a combination of like the datum, the redeemer, and something else all put together. I can get it for you, but it's pretty ridiculous, is what it is.
Why it
So
exists? I know there is a reason, but why
uh,
we need it in a transaction, you know?
just you know, I don't know.
It, it's because it's in the signed part of the transaction. So
Yeah.
it's a checksum of all the unsigned data or a hash of the unsigned
Aha, I
data that
see.
itself is signed. So you can trust the hash, but you don't
I
have to
see.
sign all of that extra data. So
I
that's why
see.
it's
I
split
see.
that way.
So yeah, for those folks, they don't know transaction. This guy is actually two parts. One part is transaction body, which is everything that we were witnessing in that tool as well, and another is witness set. Although we call it witness set, but this place is a place for adding the redeemer everything as well. So it's not just for signing a transaction, but it is a place for adding redeemers as well. And these two parts needs to be connected. And now I understood that how they are going to be connected through a script data. Thank you, Aurora. I didn't know about that. But I just want to look, you see that it witness set, guys, this is the place that we have issues. So we have redeemers. Sorry, where did I? Okay. Redeemers, we have three redeemers because we have three contracts in this transaction. And you see that there is this tag, and okay, of course, tag is fine, but there is this index. See, now it's index 2, index 0, index again 0. So in inputs, we have these 0, 1, 2, 3, right? So these are the inputs, and they are, I mean, of course, this is the index, but this is the index of the UTXO itself. It is not the index of that UTXO inside this transaction. It's kind of separate index. So these index are related to the redeemer. So for example, if this UTXO coming from a smart contract, we have to provide a redeemer in order to spend it, send somewhere to do anything to this UTXO. We have to provide the redeemer. So the redeemer needs, and so the whole node, the transaction building, everyone in the blockchain needs to know this redeemer is related to this guy. How they are going to be related by this index. So the issue we are facing, for some reason, these numbers changes along the way. We don't know how, why. And these tags end up for different UTXOs. So this tag is not actually, this 0 is doesn't belong, sorry, this index, not the 0. This 2 doesn't belong to 2, actually. It does belong to another UTXO. But for some reason, this changes somehow, and we need to look into it. So that's how we are trying to figure out this problem, but it is interesting and it's very great tool. And invalid auxiliary. This is, I think, the metadata as well, auxiliary data here. We had another auxiliary data hash. Maybe that's another thing that we will add the metadata here, but the hash of the metadata will be end up in here or something. But that's the thing. But I want to show you the transaction, how the transaction will actually look like. It's complex, but uh, if we kind of ignore the other parts, like how you craft the redeemer datum, everything just if you just put that aside, the whole transaction building part starts at this line. We add collateral for spending anything from a smart contract. You need to have collateral. And actually, there was a time I was able to spend this collateral. Normally, we don't spend it because if your transaction is not successful, most of the time, like 99.99% of the time, you cannot submit it at all. But if you are crazy enough, you can do that. And I'm happy to announce I was crazy enough to do it. And it was interesting.
Nice.
So I hope you don't, but because you are going to spend, I mean, your ADA will be gone, like this UTXO will be gone. So you have to spend it. And then there is this add loaded UTXO, which I talk about. It is a place to add all the inputs and all these things, which we saw here. I mean, some of these inputs are coming from that uh, here. And then collect from. If you want to spend a UTXO from a contract, smart contract, you need to use collect from. Um, and then you need to provide the pointer to the UTXO that you are going to spend, and of course the redeemer. And then since we are doing two UTXO, I mean it's a complex transaction. We are spending two UTXO in this transaction and burning one token. We have to collect from. So one UTXO come from another contract, and one UTXO come from, let's say, contract one. This come from contract two, and somehow along the way, these indexes, which I talk about, mixed up. And of course, the add input, if you want to explicitly input a UTXO, like say, hey, I want to put it here because my contract needs it or something, you need to use add input. It's basically just, again, give your pointer to your UTXO. And then add reference input. Add reference input, if you guys remember, we talk about read-only UTXOs. The UTXO that we don't spend, but we bring it to transaction as a witness, uh, which will end up in this place. Where is we saw it here. Output, mint, collateral, requires signer, reference input. So these are. So reference input can be a UTXO that you need its datum, its value, the data, its carry, or the uh, the contract, the CBOR code. These three, in fact, all of them are holding the CBOR code of a contract. So since we need them, we have three contracts are involved in this transaction. Therefore, we have three reference inputs. So yeah, that's one. And then minting, which is, although the name is minting, but we are burning, like this -1. And it needs a redeemer as well. And of course, at the end, there is one pay to contract. We are again sending back, we are updating the UTXO This is the address of the contract, the datum we are attaching to that UTX. So the amount, the ADA amount, if it is in line or not. Well, it is in line. The datum is in line. We have several options for datum. We can have datum hash. So the hash of that datum will be attached. We have something called embedded datum. Embedded datum is kind of look like inline, but it is not inline. Still, you have to provide the datum in the transaction. And we have inline datum, which essentially you attach the whole data to the UTXO. And then we have this token authentication token, which will attach to the UTXO as well. And then pay to address, the user address, and then we are going to send. So the user needs to have a token in order to initiate this transaction as an authentication token, sort of. So we just bring that token in the transaction and again send it back to the the user, and we cannot use it as a reference because we want them to prove they are the owner. How they can prove they are owner? By just signing. It requires signer. So here in this complete function, we have a function called evaluatex, and it sends everything here to block frost to return the memory CPU execution, which you guys saw here. These are the memory, and steps are related to CPU. They are the picoseconds needed for computation of this specific UTXO evaluation or validation. These are picosecond, like the time CPU needs for evaluation in picosecond. And this is the memory. Of course, all of them are protocol parameter. You guys can read about it. It can go above. So it is right now it's limited, but it can go above. And then where the part I wanted to talk. So there is this part I explicitly again call evaluate TX and send the TX byte. The TX byte we talk about, I send that to this exact same function, but when I do this time, it returns empty, which is a sign for error. There is a problem, and we still don't know what happens from the complete, but between complete, which exactly in this complete, this function being called, till several long later here. The order of indexes, of inputs and the redeemers changes and we are not signing. I mean, there was a signing for, admin was signing, but now it is not. So first of all, any question, anything? If not, I just want to show the error actually. Want to run this thing? Let me run it. So I have a kind of dummy code for running this thing. It query the backend to craft that transaction, send that transaction to front end, and then submit it. But since there are errors, I have to do it manually. But I just want to show to manual as well that once you craft your transaction, uh, essentially you can send that CBOR to your front end, that's code, and sign it and submit it. You see this TX submit via your JavaScript, via your wallet, via your block for us, anything. It doesn't have to be Go, but if you have the correct seaboard, you can sign it. But since we have problem, I have to do it manually here. And the other point is Apollo itself. Of course, Chris showed, but of course, Chris showed we have a TX submit. I mean, they built a TX submit, but Apollo itself have TX submit as well, and it works right now with Block Frost and Maestro. Up, up. Uh, Let me bring the latest version of the Apollo. So I think last week Eduardo pushed the latest version to Apollo, and now it supports Maestro chain context as well. And in Maestro chain context, we have the TX submit. Let's go. I think it would be at the end. TX submit, TX, so TX
And
submit.
I know
So
we're at
we have TX submit.
just in case anybody has to drop, I know we're off at time, so well let's wrap this. We can definitely finish, but don't be shy if you have to go.
I'll keep learning as long as you're talking. So
Go for it. Yep, keep it going then.
Okay. So now I just need to connect my wallet. So let's assume you have a user and the user connects its wallet, and now user uh, initiate that transaction by doing an action. And here the action is selecting a wallet in this simple front end. So once I click Eternal, this thing goes to build that transaction, and I mean, craft a JSON, send it to the backend, and build that transaction, which we are going to see it. But let's see. Okay, cannot proper TX hash. Why is that? Let me see which function is. Okay, this function is not. Which function was working? Okay, this is the one. This is not the one. But as you can see, I'm doing very, dirty coding. So, but this is the idea. I get the information from user wallets, get the different information from other places. This is a token. I just convert that to different, and this is a standard for CIP 68. If you want to support that in your application, like the datum and the metadata, if you want to match them, so these are kind of interchangeable and they understand each other. You need to follow a CIP 68, I think. Yeah. And then you have to have two different tokens. We can talk about it later, but that's the idea. And then after doing several stuff by Lucid, I craft a body to send it to backend and say, okay, this is the address, user address, this is the change address. So if anything wrongs happen, if the collateral was spent, where those leftover needs to be sent, the user UTXO, collateral, asset name, everything. You see that all these things needs to be sent to the backend in order to craft that transaction. And then I send this link, and then once I get the data, I will use this unsigned to hop the signing method. We are going to see it and then submit it. But one, because the transaction is problematic, if I submit it, you guys will see that okay, there is an issue. There is an issue. So let's again click on that. See, does this thing work? Um, why it is just calling the TX hash. Never. Maybe I don't have collateral for some reason. Or was it this wallet? So let me again run it again somehow. Honestly,
It's not the network, is it? No.
no, it is just a stupid mistake that we don't know. So we don't need to spend our time for it. But right now, the thing is happening is just I sent that query to backend. Backend got that, but this is the thing. So since I'm debugging, I get the CBOR of the transaction, but inside the transaction, inside this CBOR, if I deserialize it, I can see that sorry, control R CBOR. That's okay. We have these numbers, which means things are working and I can submit it. But if I call the same function again, which I called it, it returns empty because there's a problem. And because there's a problem, I cannot submit it via this, this system. Backend craft this CBOR, send it to front end, and I'm doing all this thing. So I'm going to do this manually. And the manually would be instead of putting this guy here, like, okay, get the data from this guy, putting the whole CBOR here and just commenting this out so it doesn't query the front again. But if I run this again, we should see a pop-up of wallet. Let's say, okay, we have it. So now we got this pop-up for wallets. Say, hey, here's this transaction. It's going to be the fee this much. This is happening. Three UTXO as reference, three contracts. These are the inputs, and then there will be output, and everything looks fine, right? So let's submit it. So once you sign the transaction, you can submit it. And let me find my passport. Uh, then here for Cardano, which is the handshake. And if I do this and sign it, uh, here in the transaction part, we see that if I just remove this guy, say the submit transaction. So it is kind of pending, but suddenly it become invalid. So even the wallet say, sorry, I cannot submit this transaction. And why? Because this is the reason. This is the reason. And the reason is saying that there is a missing redeemer. But we don't have missing redeemer. And there wasn't any problem because if there was a problem, we shouldn't get these numbers. We shouldn't get at the beginning, like that, if because that byte
Right.
or AKA this CBOR was sent to Block Frost. Block Frost did evaluate it. It was fine. It was a submittable or it was able to submit it. But now after something, I don't know, something happens, and we have this issue that the index of inputs and the index of redeemer aren't or matching. But yeah, this is the issue we're facing. And yep, any question?
Huh. That's a good description. It makes sense. And this is not a Go problem.
This is we still don't know, but since we face a similar issue regards to sorting, list are not deterministic. Maybe something happened in the memory, like this transaction in the byte format, in this CBOR in byte format changes somehow, and the indexes also changes. Therefore, we got the CBOR which is not correct. So essentially this CBOR wasn't submitted to Block Frost in order to get this guy. These execution memory units, which send that signal to us. It is a working transaction. This wasn't the CBOR. The CBOR was sent. We never get it. That CBOR is different because this CBOR is not okay. There is problem with this CBOR. So yeah, that's an issue, but that's a complex. So once you have complex transaction involving several contract spending from one, this happened. But we had some kind of same issue with a trick. People call it zero withdraw, which is you're bringing a, a contract, withdraw contract here. You can bring a staking contract, put your everything inside everything by I mean, everything evaluation, like all the logic you want to evaluate UTX inside it. But the good thing is, for example, in this transaction, we had to put two redeemer for each specific UTXO because it's two UTXO, two input, two, and this if you have a UTXO, especially in DEX like 5, 10. Essentially, you cannot build that transaction anymore because it's become too big. But what it does in a staking, this is interesting use case. You can use one redeemer for as much as possible UTXO. So you can put one redeemer here, and your input here can be hundreds. And that redeemer will be run just once for all of those UTXOs. Whereas in a spending or any other contract, you have to run one by one and each by each, kind of. But we trusted and the Apollo, and it works phenomenally great, no problem at all. We can talk about it in future. Zero withdraw trick.
Yeah, I like that. Manuel, what do you think?
Okay.
Awesome. Thank you very much. I have a lot more homework for this week to do, so we'll see how far I get until next week.
Sure.
Good.
Sure. And sure, next week we can talk about these more. But James, when do we want to start the the kind of, I don't know what should we call it? The task we talk with Chris and Eduardo regards to Go and using Andamio contracts for those tasks.
Yeah, yeah. I think we've got the structures in place now to be working on that. So we spent the first few sessions just getting up and running.
Yeah.
I've been offline the last 2 Mondays. So just excited to be wrapping my head around things again. And thank you for driving Mix today. So yeah,
My pleasure.
I think next step is over these next few weeks. There are two really productive approaches we could take. One is building Cardano Go course content, and the other is building functionality into Andamio CLI. And it really doesn't matter which one we do first. So let's spend a minute to think about that together this week.
Sure. Sure. Great. So see you next week, guys.
Yes.
Yeah, thanks everybody.
Thank you, everyone. Have a great day and night.
Thank you.
Goodbye.
Likewise.
Good.
Bye-bye.
Nice to meet you all. See you soon. Bye.